I'm going to show that. So that goes on 4 and use 1. This tip comes from AWN. You get intercottons, leathers, and you also get the 1000 volt PVC gloves. Inner for the cottons. You have the back. Let's bring it next. The other one check first. Over the front door, there's no lease. Good. Now, for the lease. I made a connection here at the earth stake. What I need to do is make sure that, first of all, my IR test will come ohm meter is actually 0. So I've shorted out both the red and black lead there, and I'm going to push that down, and I'm just going to 0 that the other way. There she is, a bit of a, and I'm just going to make that 0, just take it down a little bit. Yeah. And we can see that the second blue line is the 3 ohm scale 3, 2.52, 1.51, 0.50. Looking directly above it, I have the 0 ohms there. Now the next thing I need to do is actually measure the ohmic resistance of the coil of wire, which has become my trailing lead. To do that, I put one end, the black lead on one end of the cable, one end of the earth wire, and then I put my other lead, my red lead, and that's telling me that the total ohmic resistance there is just over, or very close to, can you see that? What does it say? 1.5? Yeah, 1.5, right? So that means whatever reading I get now, when I go around the other side, I have to take 1.5 ohms off, because that's not going to be there. Okay, so I'll meet you around the other side. So we're back around the other side, and really, all I've done is just, it's like having an extra long black cable. By joining that to that, I've now got sufficient length in my black lead so that I can measure. Now in the real world, that earth electrode is going to be underneath the switchboard, and so you could be working on the other side of the house. So you could be 20 or 30 metres away, hopefully not 30 metres away, because that's going to be a problem if you are that far away. But at any power point now, I can go along and just make sure that I have continuity with the earth stake via earth electrode. And so I'm still set up on the 3 ohm scale, right? And whatever reading we now get, let's have a look and see what reading we get, yeah. And I've got 1.5, okay, so that's what we had before. But this time, we've got the current, the little tiny current that this has for the calculation to make the ohms possible as you read it on the scale, to drive the needle, right? That's now going to travel from the earth wire back to either board, depending on which one you're going to use, and it's then going to make a circuit to that. So the total resistance that you can have between the earth electrode to your board is, it's got to be less than half an ohm, and if it is, then it's compliant. And so if I read this here, and it shows me, now if it said it was 2, right, that would be 2 minus 1.5, then that would be half an ohm. But because it's such a short distance, it's negligible. So that's actually compliant. So just testing the combi tester to make sure that it's working. There she is, pressing that little test button. Now what I've got to do is make sure that I don't have any voltage at the final sub-circuit on that frame. Okay, so if I've got a breakdown in the insulation, lights up the frame. If the earthing system's not good, that'll hold tough voltage. So we put the gloves on before, make sure there's no holes, leave over in you, but okay. Question. Also in. Here. Have a look to make sure there's no leaks. That's looking pretty good. Okay. And then with these. And I'm just going to join this to my trailing lead to make sure now I'm doing a test for the voltage. Right, so I've got a contact for there. Just making that easier for myself. And what I'm going to do, and there we have the voltage being confirmed. We'll just do that again. And it's going up to that red one there, that second one, so that tells me there's 230 volts. Right, so you can see that second one there, and there it says 230 volts, just there. Alright, so I need to make sure that I don't have a touch voltage on my motor. I need to test 3 points. Dust. Nothing's coming. I'll just do that again just to make sure that, yep, so I've still got a decent. Nothing frame. Touching at least 3 points there. Alright, so that tells me that there's no voltage on that frame. Now what I might just do it while she's running as well. So now she's running, just to be on the. Now you may not be able to do that if your motor's burnt out or it's got bad bearings. The last thing you need to do is run the motor. So that's definitely got voltage there, that's made with contact. Got no contact there, 3 points. Right. And yep, I can turn that off. My motor has no touch voltage through any breakdown in the insulation, so that it lightens up the frame. So now that I've confirmed that there's no voltage on the motor frame, because that's what we did before using the combi tester, I'm going to just use the control circuit here to just check to see whether I've got earth. Alright, so I've still got my trailing lead connected to the earth electrode that's on the other side, and if I go there just to double check, there she is, that's the 1.5 we're looking for. I want to see the same thing here on the earth, I want to see 1.5. This time I've got about, oh you know, that's actually coming up to 1.5, a little bit above 1.5, which is the resistance of the earth through the conduit, through here, via the ducting, back up into the board before it meets that. So we've got about 1.5 and a bit. So it's only a small amount here. So now I can confirm that if I have any voltage on the frame, the earth stake on the other side, which is buried in the ground, because the earth is so big, is going to basically pull down the voltage of earth potential. So the earth stake will drive the voltage, if there is a fault here, down to earth potential 0 volts. So if that's sitting at 120 or 100 volts, because it's connected to the earth electrode, that's 1.2 metres in the ground, that's going to suck the earth potential down, the voltage down to earth potential. Before we touch the motor, it's not got a touch voltage. This box here is a simulation of that, so instead of having to take this off and apprentices always going in there, I've now got my terminal box simulated over on this side. And what I have is a red, if you want to bring that across, the red wire there on the A phase, white wire on the B phase, the blue, which should be a dark blue on the C phase, and we're using one of the 3 phase colour codes, the brown, the black and the blue light blue. But the problem is that this is why in star configuration we've got an earth, there is no neutral. Now many of the rigs around here are 24 volt extra low voltage for the apprentices to work on. In the refrigeration trays we use, for whatever reason, 240, 415 volts. Okay? So we must understand that this is actually operating at real world voltages. If I turn on my, I'm just going to change back over to my black table. I've got my meter set to volts. I now have a motor which is running. So power supply is connected to earth by voltages. I go to the earth lug with the black lead. I go to the red phase here, There's my connection. I go between there. I have 244 volts on the A phase, or the red phase. I have 245 volts, on the white phase, or L2. And I have 243 volts on the blue phase, or L3. Okay, between the phases, from red to white, I have 424. From red to blue, I have 422. And from white to blue, I have 423. Pretty well balanced. Now what I've got to know is what circuit breaker isolates this. Now in this instance I do have an isolation switch, but I'm going to ignore that's there for the moment, and I might find that this board is somewhere else. So what I'm going to do is I could have an assistant on site, be the apprentice or a trade assistant, and he's going to go over the board, have a look at the board, and legally the board should be labelled. But we can't always trust the board, because people can come along, take one of those out, shove things along, put another breaker there, and it's no longer labelled what it is. So we have to do a visual on this, and we have to confirm it, and we need to confirm it more than once, because there's plenty of times when you turn something off, you go off as well, and it's just a coincidence. So we want to do this a couple of times to make sure. Right. Now, there is only one three-phase breaker on this board, so I imagine that this will be the one that turns the power off. So I'm going to do, pop that up there like that. I'm going to put this onto the voltage, I'm now going to go between the A and the B phase, the red and the white phase. I have my 424 volts, and considering that there's only one three-phase breaker here, I'm going to turn that on. And indeed, the motor stops turning, and I've got no power here. Okay, so no power on that phase. A to C and no power from B to C, and to earth, which I should expect 240. I have none of those. I'm going to put this back on, turn it back on. I need to press the start switch to get that back up and running. I'm going to put that back on, and I'm going to see what happens with now 244 volts between A and earth. I'm going to turn that off, and my isolator appears to be working. Okay. Now, there is a lockable, there's actually provision on the three-phase switch to allow for us to put a padlock on that range antenna. Be warned that I have seen motors connected to VSDs with switches that look like that. You think it's a big three-phaser, but in fact it's a data cable which goes off to a VSD, and all it does is turn off the gate. It won't isolate necessarily the 415 volts or the 240 volts. Should someone come in the plant room and override the gate that is turned off. So just be careful of that. To be very, very safe, what you need is to be able to isolate the circuit from the point of origin. The point of origin is the switchboard. There she goes. That's now been turned off. What we want to do is, we've tested before we touch, we're now going to lock out and tag out. It's even on the, if people put that on there, lock out and tag out. So we're going to do that. But to lock it out, I need my little lock dog. Our little lock dog, eh? And you pop him on like that. A bit harder with the gloves on. I'm going to stay with the gloves just to show you it's not impossible to do with the gloves on. Turn the old screw until she doesn't want to go anymore. Don't overdo it. We can now, that can't come on anymore. I'm going to throw on my danger tag as such, like that. Thread that through that way like that, push it in like that, and take the key. Now, this is protected from inadvertent or accidental re-energisation of the power. The old girl is completely isolated, and we can double check that by making sure the meter is on volts, AC. I have no voltage there. I can press here. This, that's not going to come on. I've got to make sure that the isolator there, let's just turn the isolator on for fun, just to see whether or not I can get it to turn it on. No voltage has come up, and now I'm nothing to it, she's all sweet. Very good. I said rather than putting that on. So I'm going to open up the motor. Still got gloves on this point in time. Okay, and I notice the colours here of my supply cable, red, white and blue, and on the load side of the motor I've got brown, black, light blue, and I've got my earth cable there. I'm going to use my combi checker again, just to make sure we don't have any voltage here. It should be noted at this point in time too, because the board is actually remote, I should actually hang while I'm testing this, but don't just hang it off that up here. So if that's the case while we're still testing, remember I've still got the gloves on, I'm still going to test for the voltage, right, at that point. So I have no voltage there at the moment. So by turning it back on and turning it on here, I can use my combi tester. And I've got power on the red phase, power on the white phase, power on the blue phase there, and I can turn that off. I've got my data tag hanging off it, and now I have no power. Okay, pressing the control circuit, which is only one of the phases, nothing's actually happening. I'm now going to get my lock dog so that I can lock it off so that the circuit cannot be inadvertently re-energised accidentally or up, like that. Like that, at this stage I can take the gloves off. I'm going to put my danger tag on like this. And like that, take the key out. So at this point in time, we go right on the danger tag. Person's name is putting it on, whether she or me. The date that it's put on, you need to sign it, and also you can put your phone number. So there's 4 pieces of information you can put on that. So now what I'm going to do is record any information that's relevant to making this recommission is much easier at the time of reconnection. So I'm going to just draw the drawing here of the switchboard, just not something I can see the lead is. We've got circuit breakers along the line here, and we've got 3-phase breaker there, like that. And next door I have a single phase there and another single phase. None of these are open. So I can just write little notes like that's the first breaker. In this case it's a 3-phase one. Now unfortunately that breaker has information missing because it's all been bumped out. Okay, so I'll put that there. Down on this one, I'm going to show the actual terminal block like this. I've got red there, I've got white there, I've got blue there. I have brown, so that's coming from the supply. This is coming or going to the motor. Right, and those colours are brown, black, and blue. Plus we have an earth, there's no neutral, so that tells me to start connecting the motor. When we tested the motor before, we saw that it was running in a clockwise direction. So I'm just going to write clockwise motor rotation at the cowling. Okay. If you've got that, is that all good? If you've got that, you can take a photo as well, and we can keep a copy of that, not to be lost, so that you can put the job back the way it was. What I've done is just mark it there as the first 3-phase breaker. Some people like to put an X, and that identifies it as such. Now, technically that should have the current by the IN, which is the nominal current of the breaker. It should also be labelled, so whatever motor it is, whether it's a cool pump or a hot water pump or whatever. What I'm going to do now is remove the cables, all the motors are being completely disconnected electrically from its cabling. I'll put the brown out first here, I'll put this in the need. I've already written down here what order these go in. It was brown, black and blue. Top, if you like, the bottom, or the furthest away, the closest. And now I'm going to take care of that. Now, as I said, this is the breakout box. Normally what you would have is this would be hanging out, but it's the opposite way around in this case. What you'll also be given is a J box to put these. Just taking off the locking nut for the termination adapter, which is now I'm going to use my screw connectors just to cover up the their copper. So I'll just do it in red black on here. And we don't need to use the earth because the earth has got a spade, double wall spade connector on it, and it's insulated. Now if this, as I say, was sticking out of the box, we need to put a J-box on. I'm going to grab one. Right, so stop. The J-box, tubes, running like this. That way, now as I say, that would be the other way around. That completely isolates any wires. Should someone try to re-energise the circuit. Now, once that has been disconnected, there's no way any power can get to the terminal of the motor or the frame. So that motor is now good to disassemble from the mount. You may want to do some mechanical witness marks or something like that for easy installation, taking over any shims or hacking, if the motor getting taken away to get reconditioned, and or to put a like-for-like plate. I'm going to come back, and I've got my drawing, and I need to do a couple of checks, just to make sure that there's nobody's been tampering with it. So I can do a visual inspection. I can see that there might be another person too, by the way, but I can see that my danger tag is still on.